Okay, now we are dealing with the same problem that we are dealt with in the today's class. Okay, so this is a problem here is a simple problem on equilibrium of concrete bodies. It is on Lamin's theorem, or you can say on summation of x equal to 0 and summation of y equal to 0. So the question here is to find the forces, to find the reaction force as well as tension force here. Okay, so given as weight of the ball as 100 newtons. Okay, so you can see here the ball is tied to a wall using a string here. Okay, now first we'll draw the free body diagram. Okay, I'm considering a ball here, so we know that what weight will be acting vertical downwards, so I'm drawing here weight is acting vertical downwards, weight is equal to 100. Now we know that at every contact surface there exists a normal reaction which is perpendicular to the contact surface. Now we can see here the contact surface is perfectly vertical, that means perfectly horizontal contact surface, that means here it is 90 degree. So we'll call this N, or you can say R1, R2, anything. Okay, next, remember always when we talk about flexible materials like string, rope, wires, etc. in engineering mechanics, there exists a tension force. Tension force means a force which is acting away from the body or away from the joint. Now here there is a tension force which is acting away from the body. This is tension force. So where it is acting, if you don't understand, at this point just imagine a coordinate system. Okay, so it is acting in the second quadrant, angle of inclination 15 degree with vertical, so 15 degree with vertical. I am drawing the same thing here. Ball, weight is acting downwards, and N is passing through negative x-axis but acting in the positive x-axis, so it is N, and tension force acting in the second quadrant, angle of inclination is 15 degree with vertical. Okay, so it's a coordinate system, x-axis, y-axis, W and T. This is 15. Okay, after that it is very simple. Apply Lamin's theorem, that is each force is proportional to sine of the angle between other two forces. So T divided by sine of the angle between other two forces, W and N is 90, sine 90. W divided by, when you consider W divided by angle between T and N, that is here it is 90, here it is 15, 90 plus 15, that is 105. And N divided by sine, I want this angle now, I want this angle, that is 180 minus 15. That is 180 minus 15. So if you solve this, you will get the answer as 103.5 or 26.7n. Or if you don't understand, just use summation of x equal to 0, summation of y equal to 0, you will get the same answer. Okay. Okay, students. So now we are solving the next problem. So here you can see here it is a string A, B, C, D. Okay. So A and D is tied to a wall. Okay. Now we need to find here the load at this point. What is the load at this point? And the tensions in the string AB and CD and BC. Okay, AB, BC and CD. Okay, so what is given here? Here the load is 600 here. Okay, the angle here is 30 degree. The angle here is 60 degree with respect to horizontal. We need to find the load at this point and tensions in the string AB, BC and CD. Right? So now first we'll consider joint B. Okay. First we'll consider joint B. We'll apply equations of equilibrium, that is summation f of x equal to 0, summation f of y equal to 0. Okay, that is summation of horizontal forces equal to 0, summation of vertical forces equal to 0, and then we'll equate it. We'll find the force in AB and BC. Now we got the value of FBC, and then we'll consider joint C. We'll find the value of P and value of CD. Okay, so first consider joint B. Consider joint B. Right? Consider joint B. Now you can see here it is your joint B. I am marking the joint B here. So let this be your joint B. Can you see this? This is joint B. Let this be your x-axis. Let it be your y-axis. Right? Now you can see here I am drawing the same here. So to understand, let this be your x-axis. Let it be your y-axis. Right? So now you can see here FBC is perfectly horizontal. It is given in the question. So FBC is perfectly horizontal. It is given in the question. Remember here in equilibrium of connected bodies, what we are doing here is at first we'll assume all the forces as tension forces. At first, we'll assume all the forces as tension forces. What is the meaning of tension forces? Tension forces means the force which is acting away from the joint or away from the body. Now, FBC, okay? So, FBC, So this is FBC acting away from the joint. This is FBC. Next, FBA. So you can see here, this is your y-axis, x-axis, x and y. So FBA acting in second quadrant, right? Second quadrant. So see here, this is FBA. Tension force means the force which is acting away from the joint. So this is FBA, or you can say FAB. Now what is the angle of inclination? You can see here, it is 30 degree with respect to horizontal. If this is 30 degree, that means here also it is 30 degree because alternate angles. So this is 30 degree, right? And then W is acting vertically downwards. So W is acting vertically downwards. The value is 600 newtons. The value is 600 newtons. So here, as there are only three forces, you can apply Lamin's theorem. As there are only three forces, you can apply Lamin's theorem. If you are not comfortable with Lamin's theorem, you can use summation Fx equal to 0, summation Fy equal to 0. You can see here. So according to Lamin's theorem, according to Lamin's theorem, okay. So now, first I will consider this 600. So 600 divided by what is Lamin's theorem? So each force is proportional to sine of the angle between other two forces, right? When you consider 600 Newton force, what are the other two forces? The other two forces are BA and BC. So angle between BA and BC is how much? You can see here. This is, we want this angle now. We want this angle, right? So from here to here, this is 180. So 180 minus 30, 150. So it is sine 180 minus 30. That is sine 150 is equal to, I will consider FBA now. When you consider FBA force, sine of the angle between other two forces. The other two forces are now BC and 600. So angle between them is, you can see here, it is 90. So it is sine 90. That is equal to FBC divided by angle between other two forces. Now when you consider BC force, the other two forces are BA and 600. The angle between them is how much? From here to here is 90. 90 plus 30 is 120. So it is sine 90 plus 30, that is sine 120, right? So you can see here, this is sine 150, right? 150 plus 90 is 240. 240 plus 120 is 360. So this is how we can check the Lamin's theorem. The sum of angles should be here 360. So it is 150 plus 90 is 240 plus 120 is 360. Now we know 600. So we first will equate these two to get the value of FBA, and then we'll equate these two to get the value of FBC. So FBA is equal to 600 into sine 90 divided by sine 150. Sine 150. So here 600 into sine 90 divided by sine 150 is equal to how much? You can see here it is 12,000 newtons, right? 600 into sine 90 by sine 50. Oh, sorry, it is 6,000 right here. 600 into sine 90 divided by sine 150. It is 1200. Okay, 1200 newtons. Similarly, FBC is equal to, now we will equate these two. These two or these two, we can do both. So FBC is 600 into sine 120 by sine 150, that is equal to 600 into sine 120 divided by sine 150. Sorry, 600 into sine 120 divided by sine 150. 1039.2 newtons. Okay. So now this is FBA, FBC. So now if you are not comfortable using this Lamin's theorem, you can also use summation Fx and summation Fy. See here, I am using the same now for your understanding. Now if you are not using Lamin's theorem, you can use equations of equilibrium. That is summation of horizontal forces is equal to 0, or summation Fx equal to 0, or you can say summation of horizontal forces is equal to 0. Now FBC is acting along positive x-axis or purely along x-axis, so y component is 0. So FBC plus FBC. Now if you consider BA acting in the second quadrant, so in second quadrant x component is negative, so first we'll put negative sign. Now FBA at an angle 30 degree with horizontal, so theta with respect to x-axis means x is cos, so it is FBA cos 30 is equal to 0. Next, summation of f of y equal to 0 or summation of vertical forces is equal to 0. Now FBC is purely horizontal, it is 0, y component is 0. FBA acting in second quadrant, y component is positive, so first we'll write positive sign here. Now theta with respect to x-axis means y component is sine, so this is FBA sine 30, right, minus 600 because it is acting purely along negative x-axis, that's equal to 0. So from this FBA is equal to 600 by sine 30, you can see here it is 600 divided by sine 30, 1200, so you can see here it is also 1200, here also it is 1200 newtons. Now from this equation, okay, from this equation we got the value of BA, so FBC directly is equal to 1200 cos 30 into cos 30, 1039.2, so it is 1039.2 newtons. So you can use both, either use equations of equilibrium, that is summation of fx equal to 0, summation of fy equal to 0, or Lamin's theorem when there are only 3 forces. Now I will consider joint C. So I will consider joint C, right? Now let it be your joint C. Now see here, I am considering joint C now. So what I have told you, when you consider each joint, treat each force as tension force. Tension force means a force which is acting away from the joint. Now P is acting vertical downwards, that is obvious. So one second. So let it be your x-axis, let it be your y-axis. So P acting vertical downwards, so let this be P. We need to find the value of P. Next you can see here FCD. Okay, you can see here FCD is acting in which quadrant? If you don't understand at this point, just draw your quadrants. Okay, it is acting in the first quadrant, so it is FCD. What is the angle of inclination? You can see here 60 degree with horizontal. If this is 60, that means here also 60. That is this. Alternate angles. So this is 60, right? Now FCB. Okay. Now tension force. So this is FCB. Now this is very much important. This is FCB. So remember, when you considered B joint, you have taken FBC as tension only. So when you consider C joint, again consider FCB as or FBC as tension only. Tension force means a force which is acting away from the joint. Okay. Now again, there are only 3 forces, use summation fx equal to 0, summation fy equal to 0, or Lamin's theorem. So I will use here Lamin's theorem. So according to Lamin's theorem, okay, so first consider P force, P divided by angle between other 2 forces, that means I want this angle, right? One second, let me indicate here. Yeah, I want this angle now. I want this angle. So this angle is how much? Completely 180 minus 60, that is 120. Directly I can write sine 120. That is equal to FCB. I will consider now FCB, or you can say FBC. Both are right. FCB or FBC. So angle between other 2 forces, that is I want this angle now, right? 90 plus 60, sine 150. That is equal to FCD. Angle between other 2 forces, that is 90. So 120 plus 150, 270. 270 plus 90 is 360. So from this, P is equal to and FCD is equal to. So P is equal to how much? P is equal to, so you know the value of FCB or FBC. FBC is 1039.2. So 1039.2 into sine 120 by sine 150. So if you calculate, P is equal to 1800 and FCD is equal to 2078.4 newtons. So we'll see the next problem. Okay, so here the question is to find, okay, to find tension in all the strings or wires. Find the tension forces in all the strings or wires in the given system. That means we need to find the tension force in AB, BC and CD. AB, BC and CD. Okay, we can see here there are totally 2 joints, joint B and joint C. From C, the members are CD, CB and this 500 newtons, and from B there are again 3 forces BC, BA and 500 newtons. So first you can consider either joint B or joint C, okay, and then go for the next. Okay, so what I will do here, first I will consider joint B. You can see here I will come considering joint B. Okay, so let it be your x-axis, let this be your y-axis, okay. So now, one second, yeah. So now from joint B, this 500 Newton is acting vertically downwards. So 500 Newton acting vertically downwards. Okay, so remember what I have told you, when you consider joint, okay, so treat each force as tension force. So tension force means the force acting away from the joint. Now here see, this is when you consider joint B, okay, now B acting in which quadrant? B acting in second quadrant directly. So you can write, so it is your joint or force FAB or FBA. You can write both, okay, FAB or FBA. What is the angle of inclination? Here you can see 30 degree with vertical, that means here also 30 degree because alternate angles, so 30 degree, right? Now BC force, now you can see easily BC force acting in the which quadrant? It is acting in fourth quadrant, so FBC, right? Angle of inclination is how much? You can see here angle of inclination 30 with horizontal directly, so here also 30 degree with horizontal. Okay, now there are only 3 forces, so you can use Lamin's theorem, or if you are not comfortable using Lamin's theorem, please use summation of horizontal forces is equal to 0 or summation of x equal to 0, summation of vertical forces is equal to 0, summation f of y equal to 0. So now I'm using here Lamin's theorem. So according to Lamin's theorem, okay, according to Lamin's theorem, okay, so there is no compulsion to use Lamin's theorem. If you are not comfortable with Lamin's theorem, please use summation of x and summation of y. But if you use Lamin's theorem and there are only 3 forces, the advantage is, okay, the calculation part becomes very easier. That's why I'm using Lamin's theorem. Okay, so first I will consider 500 Newton force. Okay, so first I will consider 500. So 500 divided by, when you consider a force, so each force is proportional to sine of the angle between other 2 forces. That means when I consider 500 Newton force, I want this angle. See, I want completely this angle from here to here. So what is the angle here? So you can see here, this is 30, this is 90. Can you see this? This is 90, angle between x and y axis. 90 plus 30 plus 30. So sine 150, sine 150. That is equal to, now consider BC force, FBC divided by, now what is the angle? I want this angle, right? Can you see this angle now? One second, yeah. Now I want this angle. This is from here to this is 90. 90 plus, if this is 30 here, remaining angle is 60. 90 plus 60 is again 150, right? So, or you can also do it like this. So totally it is 180 minus 30 is 150. So sine 150, that is equal to, now consider AB force, FAB divided by sine of the angle between other 2 forces. That means I want this angle, I want this angle. What is the angle here? This is 90 minus 30, sine 60. So sine 60, right? So FBC is equal to FAB is equal to, okay, okay. So now FBC is equal to 500 into sine 150 divided by sine 150, and FAB is equal to 500 into sine 60 divided by sine 150. We got the answer as BC as 500 and AB as 866 newtons. Okay, now this is for joint B. Okay, now we'll consider joint C. Okay, now we'll consider joint C. One second, yeah. I'm considering now joint C. Okay, so this is a joint C. Let it be your x-axis, let it be your y-axis. Okay, now consider joint C here. So 500 Newton acting vertically downwards here. So I will draw 500 here. So when you consider a joint, treat each force as tension force. Tension force means a force acting away from the joint. Remember? So now this is C. Okay, this is FCD force. Now we are acting in which quadrant? If you don't understand, at this point, just imagine a quadrant. Now you can see it is acting in the first quadrant because we are treating it as tension force. So FCD. What is the angle of inclination? You can see here, angle of inclination is 60 degree with vertical. If this is 60, here also 60, right? So 60 degree, right? Now other force, that is FBC or FCB. So when you consider joint C, remember, forget joint B now, just consider joint C. Now CB or BC acting in which quadrant? So tension force, that is acting in the second quadrant. Angle of inclination is 30 with horizontal, means here also 30 degree with horizontal. FBC or FCB, both are correct. So I will write it as FBC. It is 30 degree with horizontal, right? 30 degree with horizontal. Now as there are only three forces, you can apply Lamin's theorem, or if you don't want to apply Lamin's theorem, just use summation Fx equal to 0, summation Fy equal to 0. You will get the right answer. So I'm using here Lamin's theorem. So according to Lamin's theorem, right? So first consider 500 Newton force divided by, then we'll consider BC force divided by, then consider CD force divided by. When you consider 500 Newton force, so sine of the angle between other two forces, that means I want this angle now. Please see here, when I consider 500 Newton force, I want this angle, right? I want this angle. What is the angle here? So you can see here, the angle here is, okay, so here 60. What is the remaining angle here? From here to here is 90. From here to this is 90. Y-axis, x-axis. So in this 30 is here, means remaining is 60. So 60 plus 60 is 120. So sine 120. FBC consider. When you consider FBC, so sine of the angle between other two forces, that means I want this angle now. When you consider BC, I want this angle. What is this angle? Here this is 90. Okay. Now here also 90, 60 is here. That means here is 30. 90 plus 30 is 120. So again sine 120. Now consider CD. So here 90, here 30, again 120. So sine 120. So FBC, you know the value of FBC, we want FCD. So FCD is equal to 500 into sine 120 divided by sine 120. So that's the answer is 375. Sorry, the answer is 375. So FCD is equal to 500, sine 120, sine 120 cancels here. So FCD is equal to 500 newtons. So we'll see the next problem, a simple problem on Lamin's theorem, or you can say equilibrium of forces. Okay. So the question is, find reaction forces at all contact surface. Given this, the weight of the ball is 1000 newtons. Given the weight of the ball as 1000 newtons. So you can see here. Now this is ball is kept here. Okay. Now how many to find the reaction forces at all contact surfaces. Now how many contact surfaces are there? So you can see here. So this is one contact surface. I will call this as 1. Other contact surface, I will call this as 2. Okay. So totally 2 contact surfaces. Right. So now I am drawing the free body diagram. Now this is a ball. So let this be a ball. Okay. So now weight will be acting vertical downwards, you know that. So let it be your x-axis, let it be your y-axis, just okay. So now weight will be acting vertical downwards. So I'm considering weight is acting vertical downwards. Weight is given as 1000, right? Now at every contact surface there exists a normal reaction which is perpendicular to the contact surface. Now here it is perfectly vertical contact surface. That means perfectly horizontal normal reaction. That means this is how normal reaction acts here. This is 90 degree here, right? So this is, I will call this as R1, or you can say N1, right? Reaction force, right? Now you can see here, at every contact surface there exists a normal reaction which is perpendicular to the contact surface. Now here there is another normal reaction. Can you see here? Now this is 60. If this is 90, means what is the angle here? Okay, so total is 180. So here it is 90. Okay, perpendicular to the contact surface is a normal reaction. So 90, here 60. What is the angle here? It is 180 minus 90 minus 60. That is 30. So here R2 is making an angle 30 degree with horizontal. Now where R2 is acting? If you don't get where R2 is acting, at this point or at this point, just imagine a coordinate system. Just imagine a coordinate system. So you can see here, this is x-axis, this is y-axis, this is second quadrant. So this is how R2 is acting. angle of inclination is how much? You can see here, this is 90, this is 60 means here it is 30 with horizontal. So this is 30 degree with horizontal, right? Now if you draw coordinate system, let it be your x-axis, let it be your y-axis. Okay, so this is 1000 newtons. This is R1 force passing through second quadrant and acting in purely along x-axis, positive x-axis, R1, and this is R2, and this is R2. Angle of inclination is 30 degree with horizontal, 30 degree with horizontal, R1, R2 and 1000. So as there are only three forces, either you can apply Lamin's theorem or you can apply summation of H equal to 0, summation of vertical forces equal to 0. You can apply any one. So first I will apply according to Lamin's theorem. According to Lamin's theorem, right? Each force is proportional to sine of the angle between other two forces. First consider 1000. So 1000 divided by angle between other two, angle between R1 and R2. So completely 180 minus 30 is 150. So sine 150, that is equal to R1 divided by, so R1 divided by angle between R2 and 1000, it is 90 plus 30, sine 120. That is equal to, consider R2 now, angle between 1000 and R1 is, you can see here it is 90. So sine 90. So from this R1 is equal to, from this R2 is equal to. Okay, or if you don't understand how to use Lamin's theorem, you can use equations of equilibrium, that is summation of horizontal forces is equal to 0 or summation fx equal to 0. So if you use summation fx equal to 0, you can see here it is plus R1, okay, and 1000 is 0 because it is y component, it is acting purely along y axis. R2 acting in the second quadrant, that means x component is negative, so minus, I will put theta with respect to x axis, that means x component is cos, minus R2 cos 30, minus R2 cos 30 is equal to 0. Next equation, summation of vertical forces is equal to 0, or you can say summation of f of y equal to 0. Now R2 acting in second quadrant, y component is positive, so R2 sin 30 plus R2 sin 30 minus 1000, right? Minus 1000 equal to 0. If you solve both the equations, you will get R1 is equal to R2 is equal to, so you will get it as 1732 and here it has 2000. If you solve this, R1 is equal to again 1732, R2 is equal to 2000. So this is the answer. Okay. So what we did here, so to find the reaction forces at all contact surface, so first we have noted down the contact surface, one contact surface, second contact surface. So at every contact surface there exists normal reaction which is perpendicular to the contact surface. So R1 will be perfectly horizontal because contact surface is perfectly vertical. Now R2, so here you can see here normal direction will be acting perpendicular to the contact surface, that means here it is 90 perpendicular, here it is 60 means remaining angle is 30. So it is acting in which quadrant? You can see here it is acting in the second quadrant. So R1, R2 and W. So R1, R2 and W. Okay, so as there are only three forces, apply Lamin's theorem or summation of x equal to summation of y equal to, you will get the same answer. So the next problem, so here the question is same, to find the reaction forces at all contact surfaces, to find the reaction forces at all contact surfaces. Okay, so first let us mark the contact surface. Okay, so here you can see there is first contact surface and there is another second contact surface, right? 1 and 2, only two contact surface, right? So now first we'll draw the free body diagram. So this is a ball here, so I'm drawing a ball here, right? Now first we know that let it be your x-axis, let it be your y-axis. Now we know that weight will be acting vertically downwards, so this is the weight which is acting vertically downwards. So what is the weight given? Weight is given as 1000. Okay, remember weight is given as 1000 newtons. Okay, so this is 1000. Now there are two contact surface, so at every contact surface there exists a normal reaction which is perpendicular to the contact surface. Now we can see here at this contact surface there exists a normal reaction which is perpendicular to the contact surface. So this is 60, here this is 90, angle remaining here is 30. So where R1 is acting, you can see R1 is acting in the first quadrant. If you don't understand where it is acting at this point or this point, just imagine a quadrant. Okay, you can see here if you imagine a quadrant, it is acting in the first quadrant. So this is R1 force, angle is 30 degree. Angle here is 30 degree. Similarly, if you consider R2, now again if you consider here, this is R2. Now where R2 is acting? R2 acting in which quadrant? Second quadrant. Okay, so here it is acting in the second quadrant. Now this is 90 here, this is 30, that means here angle is 90 plus 30 minus 180, that is 60, right? Yeah, 60. This is 60. So if you redraw the coordinate system, so let it be your x-axis, let this be your y-axis. So here this is 1000, here this is your R1. R1 is at an angle 30 degree with horizontal, and let it be your R2. Angle is 60 with horizontal. So as there are only three forces, you can use Lamin's theorem. If you don't want to use Lamin's theorem, apply equations of equilibrium, that is summation of horizontal forces is equal to 0 or summation of x equal to 0, and summation of vertical forces is equal to 0 or summation of y equal to 0. I am using here Lamin's theorem. So 1000 divided by angle between other two forces, that means I want this angle here, I want this angle. Okay, so that this angle is how much? You can easily see from here to here, this is completely 180. 180 minus 60 minus 30, that is sin 90, right? That is equal to R1 divided by angle between other two forces, that means I want this angle, that is 90 plus 60 is 150, sin 150, that's equal to R2 by 90 plus 30 is 120. Okay, if you solve this, you will get the answer as R1 is equal to R2 is equal to, so R1 is equal to 1000 into sin 150 divided by sin 90, 500. R1 is equal to 500, and R2 is equal to 1000 into sin 120 by sin 90, 866 newtons. Okay.